Hello everyone, and thank you for joining us today for the Infineta Systems webinar. The topic for today's webinar is Infineta FlowTune, a quality of service feature on Infineta's data mobility switch that prevents congestion on the data center WANs. My name is Ashish Shah. I'm the Director of Products here at Infineta. In today's webinar, after a brief background on Infineta Systems, I will cover the state of the current data center WANs. I will then discuss why the traditional QoS features do not provide performance assurances for the critical data center applications. Then I'll explain how Infineta FlowTune addresses the root cause of packet drops in the WANs and prevents congestions from happening in the first place. Finally, I'll tie together Infineta FlowTune into the overall TCP optimization feature set on the data mobility switch. We will have a Q&A section towards the end. Feel free to ask questions through our chat window, and we will address all of them towards the end of the presentation. All right. First of all, let's set the stage on the WAN optimization markets. WAN op market is divided into two segments: the north-south branch market and the east-west inter-data center market. As you can see, Infineta is focused solely on the east-west big traffic WAN market that requires much higher performance and scalability when you compare it to the traditional branch WAN optimization market. Here is a quick background on the company. Infineta has been around for about 4 years now. We have raised $30 million in 2 rounds of VC funding. We have been shipping products for more than a year now. We have a number of publicly announced customers such as Time Warner Cable, WebMD, M-Blocks, and there are many others across different verticals. Infineta counts EMC and NetApp as its strategic partners, and you will hear from us about many more very soon. Our channel partner list continues to grow quickly, and our big traffic WAN optimization solution based on the data mobility switch has won numerous product awards. As I said earlier, it's focused only on the inter-data center applications such as high-speed replication, backup, the MDK transfers, live migrations, data center migrations, and so on. Infineta's solution is built around the data mobility switch, or what we refer to as DMS. DMS is the first and only WAN optimization solution designed to accelerate big traffic workflows across the inter-data center WAN links. The DMS has been architected using merchant silicon, and it's not designed using standard servers, which is typical of all other traditional WAN optimization solutions. This high-performance, networking-centric approach to system design, along with multiple patented and patent-pending data reduction algorithms, is what allows DMS to scale to 10 gigabits per second speeds without any loss in performance efficacy. Again, it's the highest WAN optimization solution on the market. The DMS can deliver 5 to 10x data reduction for enterprise WAN traffic. It can guarantee priorities for critical traffic. We'll see those features in details. And it can be transparently and seamlessly deployed in data center networks in minutes. Our customers see a full return on investment in well under 12 months. So now let's look at some of the core feature set that the Infineta DMS provides. And then we'll deep dive onto the topic of the day, which is Infineta FlowTune. The core features from Infineta's DMS include control, optimize, and reduce. This feature set covers the entire stack from the network layer to the transport layer to all the way to the data layers. The control feature set includes traffic classification and multiple quality of service features, spanning, again, the network transport and the data layers. Infineta FlowTune is a QoS feature that we'll go into the details of in just a minute. The optimized feature sets include TCP and UDP optimization, adaptive flow management, in-order packet delivery, and flow pinning, once again spanning across the network and transport layers. And the reduction features include repeat byte suppression, our patented deduplication and compression algorithms, as well as network layer packet coalescing for more effective data reduction. These core features are supported by Infineta's commitment to high availability, which is built into our platform, as well as the deployment flexibility that we provide. Finally, the management features provide a powerful yet easy to use interface to manage the data mobility switch. All right, with that background, now let's jump into the problem at hand. When you look at the current state of inter-data center WANs, you will find that the enterprises spend a lot of money on bandwidth. That's because the data center applications such as replication and backup are very critical to the core of the enterprise business. And you will find these lines to be prevalent, especially in financial industries as well as some other industries. When you dig deeper into these WAN links, you'll find that they're highly underutilized. Surprise! Overall throughput is very commonly capped at 70 to 80% max. This is done in order to accommodate spikes in traffic, and so that the applications can get performance assurances through this additional bandwidth buffer. If the customers were to use any higher utilization of the links, it can lead to negative performance impact on these business critical applications. The reason is for this buffer is that there has not been any good way to share WAN bandwidth between different applications, while still providing performance assurances to higher priority flows versus the lower priority flows. So the most commonly used model is time of day. During the day, the WAN is reserved for critical replication applications, even if the replication is not using the entire bandwidth. Customers end up wasting the bandwidth. This leads to underutilization of the link and naturally higher cost. Only at night, for example, when the application flows die down or slow down, the less critical applications such as backup are allowed to run. The primary reason for the bad performance is packet drops. That's the main offender on the network. When you have multiple applications that are competing for the shared WAN resource, it would lead to packet loss, which causes TCP, which is the most commonly used protocol for these applications, to back off. And when it backs off, it starts slowly bringing its throughput up. And this leads to underutilization of bandwidth and also non-deterministic performance of applications, which is, again, business critical to your enterprises. Let's go into the problem in a little more detail. So there are multiple causes of packet drops, and they are not all equal. The first is WAN congestion, which leads to packet drops. This happens when a switch or a router or a link in the core network goes down, and this loss is out of your control. It happens infrequently, and the solution is to aggressively retransmit the packets, typically the TCP layer. Almost every other solution, including Infineta, offers this. And this is a pretty effective solution for data center applications for this kind of packet loss. The second type of a packet loss is WAN bit errors. This happens very, very infrequently in the data center WAN links because these are good quality links, but still happens. You can have bit error even on optical networks, typically 1 in every 100,000 or even millions of packets. You could retransmit these packets, but you could also employ mechanisms such as forward error correction techniques. Again, many data center optimization solutions offer such solutions, and so does Infineta. All right, so far so good. But what about the final type of packet loss that's caused by LAN-WAN edge congestion? This happens when competing data center applications are vying for the same shared resource, which is the WAN link. The traditional QoS solution, such as the layer 2 QoS, in which QoS priority is implemented as a set of queues. Packets are dropped when these queues fill up. They are not application aware. They just drop the packets. Such a behavior would be a good idea for service provider environments or even for branch environment where you need to drop lower priority traffic to accommodate it's a highly critical voice over IP traffic. However, if you drop packets for data center applications using layer 2 QoS, it's a bad idea for your highly aggressive and critical replication or backup applications. Let's see why it's such a bad idea to drop packets for such business critical applications. We'll use an example. So what happens is the traditional switch or a router-based layer 2 QoS that's typically employed in your WAN would lead to underutilization of the WAN links and non-deterministic performance. Let me explain. Let's say you have two applications, replication and backup. Replication is of higher priority and needs to maintain tight recovery point objective or RPO during the business hours. Backup, on the other hand, can run as a best effort service during the business hours, but still not get starved if the application is not using the full bandwidth. What happens with the traditional layer 2 QoS is that these two applications will compete for the shared WAN link. TCP will keep trying to increase its transmission rate. That's how TCP works until it hits congestion. And when it does, it backs off by reducing the transmission rate by half. Again, that's how the TCP is supposed to work. And after it drops the transmission rate by half, it slowly starts increasing the rate again. This will not only result, as you can see on the picture, in underutilization of the link, but also the application, such as your critical replication application, will have a non-deterministic performance. You will not be able to guarantee your SLAs around RPOs. This is the reason why, as we saw earlier, that the data center WAN links are over-provisioned to begin with and capped at 70 to 80% utilization. For example, if your storage admin says, I need 2 gig of bandwidth for my replication flows to meet my SLA, well, your network guy is going to give you 2.5 to even 3 gig of bandwidth to accommodate the peaks, to make sure there is enough buffer and there is no competing application. That's the wastage of bandwidth utilization and frankly higher cost. This is the problem that we're trying to solve with Infineta FlowTune. Let's see how. So Infineta FlowTune has been designed to solve this packet loss problem created by LAN WAN edge congestion. And how it does so? It addresses the source of the problem by preventing the network congestion in first place, rather than waiting for the congestion to happen and then reacting through the retransmission when there is a packet drop. So it's a preventive measure. FlowTune prevents network congestion caused by competing application flows by transparently and dynamically managing application transmission rates. It does so by dynamically distributing bandwidth credits, similar to buffer credits in fiber channel WANs, fiber channel networks, if you're familiar with the storage area. So it allocates bandwidth credits to the applications to manage the transmission rates. And these bandwidth credits are in proportion to the QoS profile. FlowTune also maintains constant visibility to all the flows and reacts immediately to impacted flows or the offending flows. FlowTune maintains the transmission rate by adjusting the TCP transmit window of the sender, such the application throughput is maintained at controlled rates. So basically, FlowTune uses TCP windows as a flow control mechanism. It's really a layer 4 or a TCP-aware flow control mechanism. We do that because Infineta is a TCP proxy solution, and that's what allows the Infineta DMS to maintain the flow control at TCP layer. Now, one of the primary goals of FlowTune is to not drop packets, right? That's the whole problem we're trying to solve. So it does not rely on packet drops to throttle the sender. Again, that's what the traditional networks do, that to signal congestion, they drop packets, so TCP backs off. But we just saw that dropping packets is a bad idea for TCP for your critical applications. So the goal of FlowTune is that not drop packets, but rely purely on TCP window management to throttle or accelerate application throughput. So now looking at how FlowTune works, let's go back to our replication example and see what happens there. So with Infineta FlowTune, you can provide the performance assurance that your applications need without over-provisioning the WAN link and effectively sharing the link with other application. Let's see how. So what you would do is our high priority replication flow will be classified in our UI as a absolute high weighted priority with a max bandwidth cap of 80%. That is, if you are a 10 gig network, it would get 8 gig of bandwidth. The backup will be classified as a low priority traffic with minimum or at least 20% of bandwidth, again to prevent starvation. What this policy does is it ensures that during the business hours, your high priority replication traffic will get 80% of the link as long as there is traffic to send. If there is no traffic to send, the backup traffic will be able to use the additional bandwidth. But even if replication is sending traffic, backup will still get 20% of the link. Again, it doesn't get starved. Then at night, when or after the business hours, when the replication traffic tapers off, automatically the backup traffic will be able to use the remaining bandwidth. No manual intervention required. So this is the policy that allows you to dynamically share the link without the flows stepping on each other and allowing the critical applications to complete in the time that it needs to complete. Let's look at this in a little more detail of what this means. So before we get there, though, let me first explain how easy it is to configure Infineta FlowTune feature. Our customers are networking folks, and so we kept our interface that the networking people are very familiar with. The configuration is very similar to what would you do for a QoS config on a router or a switch. They've taken the same concepts basically and just applied them to layer 4 or a TCP-aware QoS. As you can see on this picture, we have 8 profiles, and you can give them priority from 0, which is absolute priority, to 7, which is a lower priority. You can configure minimum bandwidth guarantees. So certain applications must get certain bandwidth. You can also configure maximum caps, that certain applications should not be allowed to go beyond beyond a certain bandwidth. And then you would do weighted round robin, just like you would do on a router or a switch. But again, this is TCP aware, which means the TCP windows will be given, TCP windows will be open in proportion to these profiles that are configured, such as higher weight would get higher TCP window, a lower weight profile would get a lower TCP window, and so on. That is it. This is all you have to configure to get the Infineta FlowTune working for your application. And as I said, the goal is to ensure that your WAN bandwidth is 100% utilized, but also that the applications get deterministic guaranteed performance. High critical applications get higher performance that we expect, and the lower priority applications don't get starved. This approach to application performance assurance contrasts sharply with those of traditional solutions that rely solely on packet drops from recovering from congestion events. And when you have packet drops, it impacts performance for critical applications. As we've seen so far, FlowTune implements a smarter, more predictable, and automatic window management algorithm that enables companies to meet your recovery point objective and recovery time objective while utilizing your WAN capacity to the fullest, sharing the bandwidth, and as we'll see, utilizing even cost-effective WAN links. So let me quickly go into that part of the discussion before we end. Let me remind you that Infineta FlowTune is part of a broader TCP optimization feature set on the data mobility switch. So let's quickly recap the main issues that TCP has, in addition to the LAN WAN edge congestion issue we just saw, there are other issues in TCP in the data center WANs that we address, and how FlowTune fits as part of the overall TCP feature set. So almost all of the data center applications use TCP as a transport. UDP is usually not very common. And TCP, the problem is that TCP was not designed to handle high bandwidth, high latency links. It's also referred commonly as long fat network. The main reason is that TCP cannot maintain high throughput over longer distance. And as you see on this picture, the throughput will go down as the latency increases or even as loss increases. And the reduction in throughput is exponential. Now you might say that, well, if I tune my TCP stack on the server, I can overcome these issues. Well, not quite. When you have multiple applications using a shared WAN link, as we just saw in the FlowTune discussion, it can, even if they're optimized on the server side for higher buffers, they cannot optimally use the WAN bandwidth because these flows would step on each other. We just saw that in the FlowTune discussion. And when they try to scale up independently without being aware of other flows in the network, bad things happen. Congestion, packet drops, non-deterministic application performance. So the way Infineta addresses the solution is by implementing a fully transparent TCP proxy as part of a velocity transport engine, which is, again, a feature set around TCP optimization. And this allows DMS, by proxying the connections, to maintain high TCP throughput even across increasing latency from 20, 30, 40, 80, 100 millisecond to 300 millisecond across the board, or increasing loss. Through our aggressive TCP feature set, we can maintain practically no degradation of throughput, even if your latency, which is the distance across which you're transmitting the data, or the loss increases. And by the way, Infineta DMS is the only solution that can scale to 10 gig per solution in a single appliance. No other solution that comes close to Infineta solution. They all top out at a gig or 2 gig per solution. That's because, again, we focused on solving the data center application. So because of this high performance solution, your storage application can deliver, maintain your RPO or RTO even at very long distances or even across lossy links. We just saw in the FlowTune discussion that we allocate bandwidth among active flows and dynamically adapt to the needs of the applications in proportion to the quality of service requirements and changing the WAN link characteristic. So the pipe stays full regardless of number of applications on the flows, regardless of the latency, regardless of the loss. All right. So to sum it all up, as we saw in this presentation, FlowTune is industry's first and only TCP-aware Layer 4 QoS, which contrasts sharply with the Layer 2 QoS that everybody else implements. The first Layer 4 QoS feature in the industry. It proactively prevents congestion through dynamic flow management and provides performance guarantees for the critical data center applications. What this means for you as customers is that you can focus on your business and not worry about the WAN. It allows customers to fully utilize the WAN at any distance and eliminates the need to over-provision that's prevalent today. And you don't even have to set a percentage of your WAN as a buffer because you can effectively share the bandwidth with all applications in accordance with the QoS priorities that you need based on your SLAs for different applications. And finally, multiple loss prevention and mitigation features such as aggressive retransmissions, forward error correction, and the FlowTune for congestion prevention, you can use any WAN for your critical applications, including cost-effective MPLS links or even IPVPNs. You don't have to always go to expensive lease lines for your data center WANs. All right. So at this point, we would take questions. Feel free to use your chat window to ask any questions that you have. anything is fair, anything that you heard today, anything that you would like to hear, or anything else about Infineta's solution. All right, here's the first question. QoS, and I'll repeat the question. QoS has traditionally been a very hard problem to solve. You seem to have implemented a layer 4 QoS with FlowTune. What is it that allows you to do that, and why can't others do it, or do others have such a solution? Very interesting question. Well, first of all, let me say why we saw the problem and others possibly haven't been so far, is that our focus on data center WAN allows us to see such problems that are unique to data center WAN optimization environments better than anybody else. As I said, we've been shipping our product for over a year now, and we quickly identified that the traditional QoS that customers have been using breaks the application performance in data center WANs. And customers were routinely over-provisioning their networks. So that was about identifying the problem first. And then, in terms of the solution, Infineta, as I mentioned in my presentation, that our architecture is based on a merchant silicon. That is, everybody else out there uses an x86 platform. It's basically a server-based platform. We are a networking class company, and we are a networking class solution. So we have a 160 gigabits per second non-blocking switch in our product. We have a network processors in our product, again, optimized for network processing. And we have an FPGA. That's where we do a deduplication, a patented deduplication algorithm. So because of our networking product like architecture, we were able to come up with a TCP-aware QoS, again, in conjunction with our TCP proxy, that would solve the application performance problem while maintaining the 10 gig throughput. So others may have thought about this, or may not even identify the problem, but even if they have, it's very difficult, if not impossible, to do on an x86 or server platform without affecting latency, affecting performance, and so on. So it's a combination of our sharp focus on data center applications with our merchant silicon-based architecture that allows us to do a layer 4 QoS without affecting performance and provide customers with the performance assurances. All right, hope that answers the question. And by the way, to our knowledge, this is the first and only WAN-op solution to offer a layer 4 QoS on a data center WAN optimization as part of the data center WAN optimization solution. Okay, let's see if we have other questions. All right, here is one more. FlowTune seems to be a TCP-focused solution. Do you have anything for UDP-specific QoS features? Good question. So DMS supports max bandwidth allocation caps for UDP flows. So we saw that as part of the FlowTune, we have multiple parameters that you configure. And one of the parameters is max bandwidth. So for UDP flows, we do support max bandwidth allocation so that the UDP doesn't step over other traffic. This is in addition to the classic priorities and weights that is a layer 2 QoS provides. So we continue to provide layer 2 QoS, and we also provide max bandwidth caps. But what we find is that UDP is a very rare occurrence in the data center WAN. It's mostly TCP, but once in a while we do find UDP, and the solutions that are out there does cover UDP in addition to the TCP quality of service features. Excellent. Thank you for that question. Let's see. Okay, here is one more question. I have application servers TCP stack tuned with high buffers. Isn't that sufficient? Will your solution add any benefit to it? Absolutely. I think we discussed that. Let me get back to that slide actually. Let's see if I can go back to the slide. Yes, we discussed that, right? That even if your individual TCP stacks were tuned, the WAN performance can be choppy because each TCP flow would independently try to scale up its throughput and respond to losses by scaling back. because these flows are not coordinated, you will have a choppy performance. Whereas with Infineta, because we proxy all the connections that go over the WAN link through the Infineta DMS, we know exactly which flows are transmitting at any given time and which are not, and we can dynamically allocate bandwidth to the active flows and in proportion to the QoS profiles. So yeah, even if your individual TCP stacks are tuned, we have seen that, by the way, in multiple customers that as long as they have more than one flow, which is almost 100% of the cases, you will have competing flows stepping on each other, and we add significant value. All right, so looks like we are just out of time. Let me summarize with some more references and links that you can find for more action, more information. So you can find more about DMS as a product, including FlowTune feature, as well as the other feature set on Infineta.com, Infineta.com/products. You can find a lot of video resources, white papers, solution brief with NetApp or EMC or other partners on our resources website, as well as you will find our videos about how it works, the UI walkthrough, how easy it is to configure, and so on. And a recorded version of this webinar will be available at the same link. So thank you very much for attending today. We will be available for questions via email or phone. Emails out here, phones on our website. If you have any questions, do reach out to us. We'll be happy to address any question about our product or in general WAN optimization.